before we celebrate and have too many tacos, let's double check our data, right? It never hurts to try to make sure we're getting the same data back. So I can see that I am getting 10 rows back, right? Our result set at the beginning had 10 rows, and my rewritten query also has 10 rows. Now that's a good sign, but let's do a deeper check. I'm going to go ahead and use except. The first query here, this is our original query with the local variable here. And the only thing I've changed about it is I commented out the order by. Because what I'm going to do is I'm saying, run this first query, and I'm going to highlight except and run this as one batch. Run the first query and give me everything back except what has a direct match in the second query. And the second query here is our rewritten T-SQL version of the query. So show me all of the rows in the top query that, except for the rows that have an exact match, same data in the same columns in the second query. So if we get 0 rows back, everything matches, and everything does match. And the fact that we know that there are 10 rows in both data sets is pretty promising as well. So that looks good for our T-SQL rewrite there. Quick recap of tuning approaches that we took. There are quick fixes to this solution. Combining recompile with rewriting those joins and simplifying the join, or just using literals, does meet the challenge and get you, possibly quickly if you do that real fast, to a fast performing query. The cons to this approach are simply that these tuning tricks of using recompile or using literal don't scale well in most production environments these days. There may be times where it's fine in that environment because you just don't compile a lot, but in a lot of environments, we want to have parameterized, reusable execution plans whenever we can. There may be exceptions when we can't. So we found more reusable solutions by figuring out how to rewrite our code to push that predicate into the query that ranks. This did require a longer query that is harder to read, but we got a more reusable plan while getting under that 500 logical read challenge mark. The tuning process that we used to get there was based around asking, where does this query primarily limit or filter the rows? For many queries, limiting down the data set is a critical first step. Now, it varies in some queries. We're working with very large data sets, and those can be different. But in this case, we're only looking at specific years. So focusing in on where are we filtering the data and how can we do that in the most efficient way was key for that. And isolating one part of the query and reproducing and solving the problem there set us up to then fix the rest of the query, add it back in stages, rewrite it and add it back in stages. And as we add back in additional joins in the query, I also added in their columns in the select at the same time and checked the performance as we went so that I didn't have to add in a whole lot of stuff at once and then be shocked and not know where to go if the performance changed. Thanks so much for joining me for this SQL challenge. I would love to hear comments on the pages in the course about solutions you came up with, as well as any questions that you've got. And I hope that you'll join me for future SQL challenges as well. I'm Kendra Little from SQLworkbooks.com. Bye, folks.